Hi, we're going to talk about writing polynomials with given zeros. So if you have a polynomial and you know what its zeros are, you can actually write that polynomial in standard form. And what we need to know is if we have a certain number that's a zero of a polynomial, that x minus that number is going to be the factor, one of the factors. You need to understand that the number of binomial factors needs to add up to the degree, and polynomials in our case are going to have only integral coefficients. That means they're not decimals, they're not fractions, and they're real numbers, and our answers will be in standard form. So let's begin with this problem. We are given a polynomial whose leading coefficient is 1 and whose zeros are -1, -2, -3. So what we write is, we're going to write x minus -1 times x minus 2 times x minus 3. All that's going to be written like that, always x minus the 0. Doesn't matter if it's positive or negative. So I can write that as x plus 1 times x minus 2 times x minus 3. And now what we basically do is we just expand it. It doesn't matter which two you're going to multiply first. I'm just going to multiply these two first. So I keep x plus 1 together, multiply these two. When you FOIL this, you are going to get x squared minus 5x plus 6. And then you multiply this by this. I'm going to show you this one time what we're essentially trying to do. You are going to multiply each term here by each term in the first parenthesis gets multiplied by each term in the second parenthesis, and that's all you need to do. So when you multiply that, you're going to get x cubed minus 5x squared plus 6x plus x squared minus 5x plus 6, and our final polynomial function is going to be x cubed minus 4x squared plus x plus 6, and we're done with this problem. Okay, so let's move to the next problem. It's exactly the same process. You just need to watch out sometimes for when they give you the leading coefficient, like in this case they tell you the leading coefficient needs to be 2. Also, we have one of these zeros right here that has multiplicity 2, and I want to show you how to properly address that. So we're going to start, and it's a quartic equation, which means we have to have 4 binomial factors. So we're going to have x minus -1 times x minus 1, but we want to do it twice because it says multiplicity 2, so we're going to square it, and then x minus 4. So we have one factor here, and that counts as 2, which means we are going to get 4 of them. So, but we also need the leading coefficient to be 2, so what I need to do to make sure that this actually happens is I need to put 2 in front of this. This way it's going to be 2, but we'll worry about that too at the very end once everything else is done. So what are we getting? It's 2 times x plus 1. I'm going to reshuffle them. I'm going to put x minus 4 here, and I'm going to put x minus 1 squared here. This way I can FOIL these two and expand that. It's going to make it a little easier. So what am I getting? I'm getting 2 times. When I multiply these two, I'm going to have x squared minus 3x minus 4. And when you multiply these, when you expand this, you're getting x squared minus 2x plus 1. Okay? So what are we going to do now? Well, now we're going to multiply these two. It's a little scary at first because you multiply 3 terms here by 3 terms here, which is going to give you a total of 9 terms. And we do not touch that 2 yet. We're going to take care of that at the very end. So this, when you FOIL, well, technically it's not FOIL, but it's a similar concept. When you do it, x to the 4th minus 2x cubed plus x squared minus 3x cubed plus 6x squared minus 3x minus 4x squared plus 8x minus 4. Okay, that's what you're going to get. And then you simplify this because you're going to need to combine all the like terms. It's going to give you 2 times x to the 4th minus 5x cubed plus 3x squared plus 5x minus 4. And finally we distribute the 2. So our function, our polynomial function is going to be 2x to the 4th minus 10x cubed plus 6x squared plus 10x and a minus 8. And we're done. Next problem. Find the cubic. So we get 3, whose leading coefficient is 3, and we have these 3 zeros. So what we're going to do, we are going to set it up exactly the same way. Okay? So we're going to do x minus negative 1, x minus 1/3, and x minus 2. I know at first it looks a little scary because we have a fraction here, but the leading coefficient needs to be 3. That means we are going to write 3 in front of that. And what makes sense, perfect sense here, take a look at these two. What I'm going to do is I'm actually going to multiply by 3 to get rid of that fraction. So when I multiply this part here is going to give me 3x minus 1, which has no fraction. Then I have x plus 1 from this one, and I have x minus 2. Okay? So when I multiply these two, I'm going to keep this one for now. When I FOIL this is x squared minus x minus 2. Okay? When I just multiply all these together, I'm going to get 3x cubed minus 3x squared minus 6x minus x squared plus x plus 2. So our polynomial function now is going to be 3x cubed minus 4x squared minus 5x plus 2. And we are done. Okay. Now, sometimes you have a situation when you have one of the zeros that's given to you. Well, first of all, you don't have the right number because it says cubic polynomial here, which means you have to have 3 binomials. The leading coefficient is 2, but we only have 2 numbers given to you. But here's what you need to know. If you're given one of the zeros that's going to be an irrational number, in this case it's square root of 2, then to keep our coefficients integral, meaning they're going to be whole numbers, no decimals, no fractions, then there's got to be another one which is going to be its conjugate. So the conjugate here is going to be negative square root of 2. And that gives you 1, 2, 3 factors, and that's going to work just fine. So here's what we do. We do x minus negative 1, so it's x plus 1, times x minus square root of 2, times x minus negative square root of 2, so x plus square root of 2. You always want to multiply these two together because that's actually a difference of 2 squares. And I want to remind you really quickly that x minus b, a minus b times a plus b is going to equal a squared minus b squared. That's precisely what you have here. So we're going to multiply that. We're going to keep x plus 1. And this here is going to give you x squared minus square root of 2 squared, which gives you x plus 1 times x squared minus 2. Right? And all you need to do now is FOIL this. Oh, I did forget one thing. We do need to have 2 here because the leading coefficient needs to be 2. You can always take care of that later, but it's going to be better to do it in the beginning. This way you're not going to forget it, almost like I did. Okay, so we're going to keep the 2 for now. We're only going to multiply by 2 when we had a problem like the previous one, when it helps us to get rid of fractions. Otherwise, we're just going to multiply at the very end. So these 2 FOILed will give you x cubed plus x squared minus 2x minus 2. And we finally distribute the 2, and our polynomial function is going to be 2x cubed plus 2x squared minus 4x minus 4. All right? Okay. Same concept, we're trying to do a cubic one. So degree 3. And over here, we need the leading coefficient to be 1, so we don't need to put any numbers in front. Please note that one of the zeros here is 1 plus square root of 3. That means you're going to have 1 minus square root of 3 as it's 0 as well. And what you do now is you go ahead and set it up. So we're going to have x minus 2, x minus 1 plus square root of 3, x minus 1 minus square root of 3. And I'm going to show you a little trick here which will help you make it less painful, because if you distribute this, you're going to have 3 terms times 3 terms, and it's going to be quite challenging to multiply that. If you want to make it easier, here's what we do. First of all, we are going to distribute this, and we are going to have this, right? That's what we're getting. And what we're going to do, we're going to put parentheses around x plus 1, and I will explain to you in a moment why it makes it easier. When you put parentheses here, right here you are actually going to have difference of two squares. It's x minus 1 minus square root of 3 and x minus 1 plus square root of 3. So what you do is you continue it like this. You keep that for now. Here you're going to do x minus 1 squared minus square root of 3 squared. Trust me, this will save you a ton of time and it will help you avoid mistakes. So we get that, right? What we're going to do now is we are going to keep that and we're going to distribute this. This parenthesis here is x squared minus 2x plus 1. This here will give you 3, so minus 3. We simplify that, that's x minus 2 times x squared minus 2x minus 2, right? Now we can finally multiply all that. That's going to give us x cubed minus 2x squared minus 2x minus 2x squared plus 4x plus 4. And then our polynomial, finally, polynomial is going to be x cubed minus 4x squared plus 2x plus 4. Alright? Sometimes you're going to have one of the zeros that's going to be a complex number, that's going to have I, and then similar things going to happen here. So we need a cubic polynomial, so it's supposed to have 3 zeros, we only have 2. The leading coefficient is 1, but one of the zeros is a complex number, 2i, and then there must be another complex zero which is going to be its conjugate, which is negative 2i. And now you can go ahead and do it. So when we do that, we're going to do x minus negative 1, which is x plus 1, times x minus 2i, times x minus negative 2i, so x plus 2i. And I want to point out to you that, again, you're looking at a difference of two squares right here. And you want to multiply those first to make things go easy. So x plus 1. Here you're going to have x squared minus 2i squared. So 2i squared is going to give you minus 4. This here gives you minus 4. So it's x plus 1 is what we're going to get. X plus 1 times x squared plus 4. And you finally write that as your polynomial function, which is going to give you x cubed plus x squared plus 4x plus 4. Okay? I have a couple more examples. No, this is not, hold on, did I do this correct? Yes, I got it correct. Okay. This is our last example here. No, that's not our last example. We're going to have one more. I'm sorry. So here we have a cubic polynomial. So 3. You only have 2 numbers here. The leading coefficient is 1, so we don't have to worry about any numbers in the front. But you have 1 minus 3i as one of the zeros. That means there's going to be 1 plus 3i as another zero. And that's going to give you 3 factors. Okay, so we're going to go ahead and set it up. X minus 2, x minus 1 minus 3i, x minus 1 plus 3i. We're going to use the same trick I used with the one that had a square root. So I'm going to keep that. We will distribute this. And now we are going to wrap parentheses around x minus 1 here and here. And what you're going to have here is the difference of two squares. X minus 1 plus 3i, x minus 1 minus 3i. That's the difference of squares. So x minus 2 times x minus 1 squared minus 3i squared. 3i squared will give you minus 9. So x minus 2. When you expand this is x squared minus 2x plus 1 minus negative 9, so plus 9. So that's going to give you x minus 2 times x squared minus 2x plus 10. Okay, and what we need to do is multiply them now. And when you multiply them, you are getting the following. You're going to get x cubed minus 2x, I should probably put equal signs here, x cubed minus 2x squared plus 10x minus 2x squared plus 4x minus 20, and our polynomial function is going to be x cubed minus 4x squared plus 14x minus 20. Alright, now I have our last example, and our last example is going to actually combine this craziness with complex zeros and irrational zeros. So we want to find, let's read these very carefully. We want a quartic polynomial. So that's degree 4, which means we need 4 binomials whose leading coefficient is 1, so that's good. And we're given only two numbers, this one and this one. So what else is going to be 0 here? It's going to be 2 plus square root of 3, and you're going to have negative 1 minus I. 1, 2, 3, 4. This is what it's going to have to be if you want to have a polynomial without any complex coefficients or irrational coefficients. So x minus 2 minus square root of 3, x minus 2 plus square root of 3. So that's for the first two. Then we're going to have x minus negative 1 plus I and x minus negative 1 minus I. And we are going to use the same trick that I showed you, but we're going to have to use it twice. So first of all, let's get rid of the interior parentheses. So x minus 2 plus square root of 3, x minus 2 minus square root of 3, x plus 1 minus I, and then x plus 1 plus I. Okay, so this is what we have, and now we are going to put x minus 2 in parentheses here and here, and x plus 1 in parentheses here and here, and we're going to have twice a difference of squares, and we're going to multiply them together first, and then we're going to get both things simplified. So this is going to give you x minus 2 squared minus square root of 3 squared times, this is going to give you x plus 1 squared minus I squared. All right. I hope you see why this works a lot better than trying to multiply 3 terms here by 3 terms here. That's going to be a lot more complicated and a much greater chance of making a mistake. So what do we have here? This is x squared minus 4x plus 4 minus 3. Here we're going to have x squared plus 2x plus 1. I squared is negative 1 minus negative 1, so plus 1. That's going to take us to x squared minus 4x plus 1. From this one is going to give you x squared plus 2x plus 2. And all we need to do now is multiply them, and you are almost done. So when we multiply them, we're going to get x to the fourth plus 2x cubed plus 2x squared minus 4x cubed minus 8x squared minus 8x plus x squared plus 2x plus 2. Okay? This is why going this route is easier, because this is what happens when you multiply 3 terms by 3 terms. You're going to get 9 terms. So if I wanted to do the same thing here, I would have gotten a total of 9 plus 9, 18 terms, and it makes things a whole lot more complicated. And we combine like terms, just like we did before, so our f of x is going to be x to the fourth minus 2x cubed minus 5x squared minus 6x plus 2. Okay? And we are done. This is how you do it.